what they're trying to say is AMS circuit interface to the real world by capturing analog signals and converting them to the digital signals. So whenever you are having an AMS interface, okay, so what they are trying to say, that is a real world interface. We know that all real world signals are analog in nature. So you have to capture those analog signals through that analog interface, and you have to convert those things into digital, and vice versa for digital to analog conversion. Okay. So what all the AMS blocks usually we will see in our design is, you can go with the PLL, so that is an analog block, ADC or DAX. So these are some of the analog blocks.
PLL is the clock generating.
Yeah, that is PLL is used to generate the clock. Okay, so PLL
input is the analog PLL.
Actually, that is a block. Okay, PLL is block. The objective is to generate the clock. Okay, that block is implemented using transistors at transistor level. That is custom design. Okay, so you have to design that thing from the scratch. Okay, that is analog design. Okay, so we have to design that block in backend, right? So that is the objective. So that is a analog block. So we know that in our SOC, not only a digital block will be there, we are having analog blocks also. So during that time when we are running the simulation, so that is not normal digital simulation. We have to run analog and mixed signal simulations. Okay, so that is what the topic of today's discussion is. So the purpose of analog simulation is to verify that the DUT meets the required functionality according to voltage, current and timing specification. So that is the objective of the analog. They are only talking about the electrical specification. Okay, so what is voltage? They are talking about current. They are talking about timing. Okay, so when you are performing an analog simulation, during that time you have to talk in terms of voltage, current and timing, not in terms of functionality. Okay, but if you take example of digital, what is your objective? You have to check the functionality, whether it is functionally working or not.
But in analog, voltage, current.
Yeah, we should not talk in terms of functionality. We should talk in terms of voltage, current and frequency, timing.
My one doubt is, in suppose we get the RF.
Okay.
RF frequency, that means
Right.
transmitter and receiver.
I got.
The analog IC is there or digital.
RF is analog here, radio frequency. That is separate field. RF
But we can transmit it through the
wireless medium.
Okay. Through analog.
That is analog signal. Like all the signals are analog in nature here. Either that is analog or digital.
Suppose we can the transistor. Suppose we can the AND gate.
Okay.
We can write a code.
Okay.
Suppose similarly to op amp.
Okay.
A code is.
No, you cannot write a code for op amp. Okay. Like if you want to know some property of op amps, okay, in that case you have to write the SPICE. You know how to use SPICE code.
And that means the diagram.
No, SPICE code means you have to define the nodes. Okay, at which node what voltage is coming. Okay, that is SPICE analysis. Like for a DUT in digital, you are writing a Verilog code, right? For analog, if you want to simulate something, you have to write the SPICE code. Okay, that is at transistor level you have to write the code. Okay, so in that way you can simulate your circuit. Okay, so we'll see now. So here they have shown. So this is the analog block, right? So analog signal is analog in nature. So you see, after that you are taking that thing in digital format, right? Now this is the op amp. So this is an analog circuit, and this is a digital circuit.
Same.
No, it's not the same. It's not the same functionality, you can say, but they are showing what is digital, what is analog. So this they are showing that this is discrete signal, right? So this is digital in nature. This is continuous signal. This is analog in nature. So example, they have taken op amp, okay, and in digital circuit they are taking one mux and one flip flop there. So that they are simple. They are showing that they are distinguishing between analog and digital. The mixed signal simulation environment needs to address analog simulation and digital simulation, and then interaction between the two. First you have to perform analog simulation. Suppose you have implemented PLL, okay, you have to check that voltage or current characteristics. Okay, usually
You can check in model sim?
no, you cannot check. Okay, only model sim will work with digital simulation, not for analog.